Okay, so as Ianir said, my topic is going to be the Eastern Mediterranean as a test bed for paleoenvironmental and cultural adaptation. And it's going to focus on the recent work that I've done in Israel and Greece. And one of the things I should point out is that, you know, I'm really a desert archaeologist. I spent 40 years in the deserts of the Holy Land in Israel and Jordan doing research. But after 40 years, it was getting pretty hot. So I decided to cool off and get into underwater archaeology. And that really came about because UC San Diego decided to create a new Scripps Center for Marine Archaeology, and they asked me to be a co-director along with John Hildebrand from Scripps, who's he's a marine geologist, and together with our colleagues, we're trying to build up the new center. So that's a big part of the story here today. And to do that, we've reached out to our colleagues in the Eastern Mediterranean, who I'll mention in the talk, to make that happen. And so the big question is, how do we jumpstart Scripps Center Marine Archaeology to become an international player in archaeology today? And to do that, I would just say we dive in. And that's exactly what we've been doing over the past 5 years. And I think one way to view our endeavor is to conceptualize archaeology at any major research university as one of those few fields that can intersect with every scholarly discipline or every scholarly division on a campus, and then we can collaborate with those colleagues to produce new what we could call transdisciplinary research, that is team science. And that's what we're seeing in our field today. So archaeology for us, I mean, certainly the people on this call, is at the center, the intersection of anthropology and the social sciences, the visual arts, the humanities like Jewish studies, Greek studies, marine science, material science, the biological science, computer science and engineering, and the geosciences. This is just a view from the air of the Scripps Institution of Oceanography. And we actually have our headquarters in a nice little building right over here. And many of the people from the IAA were with us in 2019 for a conference we did here at UC San Diego that was instrumental actually in helping us secure that funding that Ianir mentioned a moment ago. So here's our team, the faculty group at the top, who's involved in this group, including Isabel Rivera Caygazo, who many of you know had worked in Israel as a grad student for about 3 years at the University of Haifa. And I would say that all roads in this story kind of lead back to Haifa, and my colleague, Professor Asaf Yasur Landau, who you see there. And to build the center, we've reached out to scholars, a number of key scholars, to help us learn how to be maritime archaeologists, because UCSD didn't have that tradition here. We're very good in environmental science. So Stella Domestica from the University of Cyprus, she's on our board and so on. And you need a team to do what we're talking about here. Well, I was a qualified scuba diver back in 1969, before many of you were born on this call. But, scuba diving was very expensive, and I gravitated to the Israel's Negev desert. So I kind of left that, but I re-upped about 6 or 7 years ago and became a science diver and so on to be able to carry out this kind of research. So we envision the Scripps Center of Marine Archaeology as made up of sort of 5 major components. There's the research that drives our work, field work, which takes place mostly in Israel, and then Greece, some in and a lot in Puerto Rico with Isabel, and then a little bit in California. We started a field school back in 2018 with the University of Haifa and Asaf, so that undergraduates could get an experience in marine archaeology. We also do research and development to help build some new tools, especially related to photogrammetry and underwater exploration. And then at the center of this is graduate teaching through experiential training. So the graduate students at the University of Haifa and here at UC San Diego and at the University of Patras have played a key role in driving the research, and that's what's very satisfying for us. If you ask me what's our dream is to intersect with research groups across the Eastern Mediterranean and all the way to China. And our faculty have research interests in those regions. And here we just see a map of the overland and the maritime Silk Roads in throughout this region as a kind of metaphor for the connectivity that we can generate through these kinds of environmental and cultural studies. And we're in the process of building that up. So an integral part of our Scripps Center of Marine Archaeology is the science diving tradition at UC San Diego. So every person who is a diver has to go through a 100-hour scientific diving course, and you earn 6 different professional qualifications to do that. It's led by Christian McDonald and Rich Walsh here, and they've worked very closly with the Haifa team and their science diver, Mr. Yurman. We also do small boating safety training courses, so we get qualifications in that, which helps us in the field work. And that was Christian, not the dummy, but the live guy. And then the Marine Archaeology Field School that you see here with Asaf on the right, and then the teams, and Amir Yurman is in the back here. He's the science diving officer at Haifa, and here's Rich Walsh, one of the officers from UCSD, John Hildebrand, my colleague here, Isabel Rivera Cayazo over here. And together we have a great team with the University of Haifa. And as Ianir mentioned, in 2020, we received this grant from the Koret Foundation in San Francisco, which aims to help build international scientific collaboration between an American research institution and one in Israel, especially to help build up the Israeli institution. And so now that the University of Haifa has created the new School of Archaeology with 4 different departments, this is very exciting, and it's really a pleasure to be affiliated with that endeavor. And here you can see Saf and I on the beach at Dor. Well, you can see why you would want to be on the beach at Dor and not in the desert all the time. Okay, so we use three main approaches to the research at the Scripps Center of Marine Archaeology. One is based on shallow marine geophysics. The other is on sediment core analyses. And the third one is on underwater excavation and photogrammetry. Marine geophysics, we reached out to Professor George Papadiothoro and Professor Maria Garaga at the University of Patras to help us build that kind of infrastructure. Sediment coring is something we have a tradition of at Scripps with my colleague, Professor Dick Norris, especially leading the way, and he plays an integral part of our research. And then the photogrammetry, we have a long, relatively long tradition of sort of cyber archaeology, digital archaeology, and the goal is to apply that underwater. And then underwater excavation, that was one of the reasons we reached out to the University of Haifa, because they are pioneers in underwater archaeology going back over 50 years. So this is a model that I came up with back in 2013 for the American Academy of Arts and Sciences on cyber archaeology, which is really the marriage of archaeology with computer science, engineering, and the natural sciences on land. But here we've adapted it to the marine archaeology environment with the different kinds of digital data acquisition, including side scan sonar, sub-bottom profiling, multi-beam, sediment, underwater sediment coring, the underwater excavation, and photogrammetry. That's acquisition. And then we have the curation of data. You know, what do we do with all this digital data at the end of the day? And ultimately, I think it should be at the library, virtually at a library at the major research university. And then we have the analyses of the data. Well, that's through GIS and other applications, radiometric dating, modeling, and so on. And then the dissemination of our data. And that, of course, is with peer-reviewed journals and publications. But then there's also cyber infrastructures like we have a digital archaeology atlas of the Holy Land with Steve Savage. And that is one way of getting the data out. And another one is through 3D visualization. And you have different kinds of platforms, including large-scale 3D environments, and then personal VR devices like Google Cardboard and so on. And then taking advantage of virtual reality. But what really drives the work, of course, is that we're archaeologists. And so it's the historical questions that are at the center of our interests. And one of those, of course, is the collapse of the issue of the collapse of civilizations that a number of people on this call have written about, like Bernard Knapp. And here we see some of the highlights from, Eric Klein's work and so on. At the end of the Bronze Age, at the end of the late Bronze Age, that collapse is a very important factor in our research, and even earlier phases of so-called collapse. So what causes collapse? I mean, there's a number of ideas. It could be major episodes of climate change. It could be social crises due to mass migrations. It can be pandemics. It can be dramatic advances in methods of transport, warfare. And how about the inability of humans to adapt to crises? That is, the lack of social resilience and poor elite leadership. Doesn't this all sound really familiar right now? well, that's another lecture on the collapse of society around here. But I'm going to talk a little bit about our Carmel Coast research off the coast of Israel between the University of Haifa and UC San Diego, that has been supported by the Koret Foundation. And early on, we got some support from the Honor Frost Foundation for our marine geophysical survey in the area. What kind of drove me to the Carmel Coast was that issue of, well, what happened after the late Bronze Age collapse, because of all the work that I had done in Jordan on the emergence of Iron Age polities after, especially in biblical Edom, after the collapse in the Eastern Mediterranean. And that was when Asaf invited me to join him in the underwater explorations off the coast of the Carmel, especially off the coast of Dor here. And along the way, new topics of research have developed. So here you can just see a aerial view of our site in Jordan. Khibet Nahas was a major Iron Age copper production site, around 10 hectares, 25 acres in size. And at the top here, you can see a large fortress. This is a project, part of the long-term research that I did for many years with my friend and colleague, Dr. Mohammed Najjar. And one of the questions, I mean, this was the peak of copper production in Fainan, even larger than the Roman period. One of the questions was, well, where did all the copper go? And for that, we have some good data that came out of the sea under through Dr. Udi Galili's research, especially off the coast of Neve Yam, where he found hundreds of ingots, copper ingots, that were part of a shipwreck from the very end of the late Bronze, early Iron Age. And when Nama Yahalom Mack did a study of the of these, a scientific study of these ingots, and looked at the trace elements and lead isotope studies, turns out that many of them actually came from Fainan and probably Khibet Nahas. So this is a really nice way of connecting the desert and the sea and seeing where these the copper was actually being moved across the landscape. And we did some underwater excavations. Roy Nicholsberg, one of the grad students at Haifa, was involved in this, and we found good evidence for Hellenistic harbor installations. And even digging around this in the bay at Dor, we also found pottery Neolithic evidence of a village kind of settlement in this area. And we published this with my postdoc, Gilad Steinberg, in PLOS ONE in 2020. And it was a big part of this study was the analysis of a large number of sediment cores that we extracted around the bay, the small little bay at Dor, where Gilad identified evidence of a Neolithic tsunami, a mega tsunami event in the Eastern Mediterranean at the beginning of the Neolithic period. And we'll see some of that here. Udi Galili did the major surveys along the Carmel coast for discovering prehistoric sites. And the bulk of them are from the pottery Neolithic, which you can see here by the where it says PN here. And then there is an earlier one from the PPNC. And but there's a very strange absence of PPNA and PPNB settlement in the area. And perhaps the tsunami event helps us explain that. Here you can see on the right is Dick Norris, professor at Scripps, who, as I mentioned, plays a central role in helping to direct the sediment studies from these cores. Katrina Contru, who's one of our grad students, was involved. There's Gilad and Tony Tamburino over there, one of my grad students. So basically, those cores provide two major kinds of data. One are biological proxy data that help us reconstruct the ecosystems of the past. So when you get the cores, you look for fish remains. It can be remains of sponges, algae, sea urchins, bivalves, foraminifera, very important, corals. And then the other kind of data we get is sedimentological data. This provides proxy information about the environmental histories of an area, in our case, off the Carmel coast. And it tells us about the origin, the environmental processes, and the anthropogenic influences on settlement through time in the area. And for that, we really need a robust radiometric dating framework for these cores. And we get that through OSL dating, optical stimulated luminescence dating, and also from radiocarbon analyses. And so here you can see the Carmel coast area. The mountains are over here. And then this is about 3 kilometers wide. It's very narrow coastal plain. Some of the most famous prehistoric sites are up on the Carmel hills here, like Kabara Cave, excavated by Ofer Bar Yosef and colleagues. And then there's Atlit, the submerged PPNC site that Udi Galili excavated. And of course, at the northern end, and then Tel Dor. And then at the northern end, of course, is Tabun Cave. So this is a world center for prehistoric research. How do we get the cores? Well, in Israel, we use the geoprobe. It's a coring device, a kind of pressure device that pushes these plastic sleeves into the sediment, and we can extract sediment cores that are over 20 meters in length and spanning the whole of the Holocene. And these stars indicate where we sampled around Dor. And there are the cores after they come out of the ground, and they're labeled, and then we ship them back to UCSD. And then what we're looking at here is a sea level curve and the bathymetry, that's the topography, the submerged topography off the coast. And we can see that in the time of this tsunami that we identified, the coastline was about 6 kilometers further out to the west than it is today. And this was quite an extraordinary study that we came up with. Mechanisms, well, we think it was tectonic, and it may have caused a major series of landslides off the coast of Israel. These have been identified by geologists, and they call these submerged landslides the Goliath landslide, the Palmachim landslide, the Dor landslide, and so on. And so that may have triggered the tsunami in the area. And here I just want to show you a brief video, and there might be a short commercial at the beginning, but just bear with me while I skip through it. So let's give this a try.
What if you could get rid of your kitchen garbage at the push of a button? Hey, I'm Matt from Pila, and I want to introduce you to my friend Lo.
There we go. When the Scripps Center of Marine Archaeology wanted to kickstart actually excavating underwater, we started our collaboration with the University of Haifa and the Rekanati Center of Maritime Studies under Professor Asaf Yasur Landau. And Asaf suggested that we begin our work together at Tel Dor, in the waters of Tel Dor, which was one of the most important ancient ports in antiquity. So that was that's our long-term research focus. And it's there that we decided we wanted to really expand our understanding of the paleo environment. So that's when we decided to bring Gilad Steinberg into the story. And Gilad, it's been so great working with you. And when we started to get the cores in this area, we worked very close to the shoreline of the South Bay of the ancient port of Dor. There are a number of small bays there. And the South Bay, we can see to my left, it's in big letters, South Bay. Could you say something about the strategy we use to core in this area?
Yeah, so in the South Bay of Dor, we used the GeoProbe, which is basically the coring rig that we mostly use in the coastal plain of Israel, that I use through my PhD research. And this coring methodology lets us retrieve continuous core records of the stratigraphy of the area. And this is such a good methodology to use, just because using this coring methodology, we can understand the environment and the changes that influence, leading to its current morphology.
So we got a number of cores indicated there, D4, D12, D6. One of those had a big surprise for us. Which one did this start to reveal? Which core started to reveal the surprise?
Well, we conducted this coring over two coring expedition. In 2018, we retrieved core D4. And in D4, after extracting this core out from the surface, I was very surprised to see this very thin sand unit.
Well, let's look at it. Hang on. Can we have the next slide, please? Let's look at it. Okay. So I remember that day. I came into the lab at Scripps, overlooking the beautiful Pacific Ocean. It can't be a better place to work. And there was Gilad, and then in walked Professor Norris in his white lab coat, and you guys were all excited. Can you point out what that layer was that you, go ahead, show me which one it was again?
So it's the lithological unit called F3. You can actually see it between two black layers.
Got it. F3. Okay. Dick, what got you guys so excited about F3?
Yeah, what we were doing was we were cutting open these cores, these tubes of sediment with a saw, and each one started to show the same kind of thing, this layer of sand in between darker colored sediments that we thought represented wetlands. And then the really cool thing about that was that the sand layer contained shells, marine shells.
Now, wait a minute. You're not we're on land. You're not talking about like land snails. You're talking about like mollusks, right?
Yeah, marine shells and little pieces of clay and stuff like that that just didn't look like a normal deposit. And what was so interesting about it was that core after core, when we split them open, we all saw very similar kinds of layers like this, which was not what we expected.
Based on these data, there's no question that we identified an ancient tsunami event in the core record from Dor.
So the key variables are what the water depth is, how big a submarine slide has been generated when the earthquake strikes, how much of the continental slope failed, basically. That creates a displacement, which is what you see in that big wave. And then there's the issue of also how far from the coast the submarine slide happens, because that determines how rapidly the wave will reach the land surface. And you can see in the model that the wave is overwashing the coastline and is presumably decimating any coastal communities that might have been there. I think another cool thing you can see in the simulation is the orange area. So that was the area that got inundated by the tsunami wave. And it's not really uniform along the coastline. So the area immediately opposite the slope failure really gets hit. And then a little bit farther north as well, up closer to the town of Haifa.
So we nailed the age of this tsunami deposit to 7,900 to 7,300 BC. And we did this using a relatively new innovative technique called optically stimulated luminescence dating. OSL dating dates the last time that sand grains were exposed to light. So we were able to subsample the cores in the dark and then bring them to my lab at Utah State University to determine how old they were.
Yeah, so we're thinking that these marine shells were transported over a distance of 16 kilometers.
16 kilometers, that's like, 4 or 5 miles, right? So Israel was bigger in those days.
Yeah, during these times, the sea level was much lower. So the coastal plain was much, much wider.
We are now at the Knuckle Oren, Neolithic settlement. This is a pre-pottery Neolithic A and Levy settlement, very large one, probably the largest in the area of the Carmel. When the tsunami was hitting the coast, it could have had a very, very strong effect on this early Mediterranean economy, impacting the fields, impacting the livestock, causing perhaps an irreparable damage that took much time to recover from. This is an event during a time in which society was beginning to form as sedentary society, and village life was in its very beginning. We can only imagine what consequences this event or this mega event had on the belief system of the people that resided here.
Childhood sexual abuse doesn't start with sexual abuse. Abusers start by gaining trust, making a child feel special and safe.
Sorry,
They
guys.
rely on this
I
trust
gotta
to
get
keep
rid of
victims
that.
silent. This is one of the reasons why survivors of child sexual abuse hold on to these secrets for decades.
Okay, sorry. That was not the best transition, but I think it's very important for us to employ as many tools as we can for scientific storytelling. And so, producing videos to go with our articles, I think is very important. And I'm proud to say that I did produce it and I directed it. So that was a lot of fun. And we did that here at the Qualcomm Institute at UCSD. So that leads us into another project. And this is the Methoni Bay Marine Archaeology and Cultural Heritage Project with Professor George Papadiothorou and Professor Maria Garaga and their teams and our teams. And this takes place off the southern coast of Messenia, this peninsula down here in the Peloponnesos, at a place called Methoni, a beautiful settlement in that area. And part of the story here is this question about whether the so-called 4.2 mega drought event, which Harvey Weiss and others have discussed a lot, had some impact during the Middle Bronze Age in this region from around 2200 to 1900 BC. And that's what we've highlighted here with the Greek chronology and various researchers. Again, the bulk of our work here, it's marine geophysics and photogrammetry, because we haven't gotten to the point where we can do underwater excavation, but it's part of our long-term plan, and we're hoping to do that as soon as we can. And this is just a kind of model that shows the various tools that we use in our research for the marine geophysics, whether we're using side scan sonar and getting seismic profiles through sub-bottom profiling. And then we use a lot of different techniques to get as accurate a picture as possible of environmental and topographic change in the area. And we couple it to date with the photogrammetry work underwater that I'm going to mention. And then the nexus of the whole system is a geographic information system, so that because all the data that we collect is it's a geospatial database. And so we can organize all these data and then load it onto what we might call a kind of digital scaffold, okay, that encompasses the nearshore and the underwater environment. And that's kind of what we're aiming for. And this is a drone view of Methone, of the Methone village and the bay. And when we drop down here, even just with a drone or Google Earth, you can see these are the remains of a submerged archaeological site from the Middle Bronze Age, the Middle Helladic times, that was first discovered by Ilias Spondylis, a noted Greek underwater archaeologist who is our friend and colleague and involved with this research. Here we're beginning to see the track lines for our shallow marine geophysics over the area, and the area with those submerged archaeological remains that I mentioned was over here. And then about 500 meters to the southeast, is a small islet called Nisiakuli. And there, back in the 60s, a Greek archaeologist made some small excavations and discovered Middle Helladic remains here at Nisiakuli. So this whole area has a strong story related to the Middle Helladic times here. Here you can see our research team. Here's Professor Papadiotoru and some of his graduate students. And this is, we take turns cooking on the boat. We have a little research vessel. And when we're doing the photogrammetry, the Greek team cooks. And when they're doing geophysics, the American team cooks. It's a lot of fun. And here's Maria analyzing the sub-bottom profiles that we're collecting in real time. And this can tell us where some features are, archaeological features are on perhaps buried in the sediments beneath the sand. Here you can see some of the graduate students, the Greek graduate students working Nikos Gregorio just got his PhD last month. He defended. We're very happy for him. And this just gives you a feeling for what it's like to do research in Greece. You can't beat it, I have to say. Working in Greece was actually, that idea was what I wanted to do in my career at the beginning of my career when I first became a graduate student, but it didn't work out. But here we are towards the end, and we're there and we're working, and it's just a very satisfying experience. Here you can see two of my grad students, Tony Tamburino and Lauren Clark, setting up the photogrammetry system, which includes 3 high-definition cameras. We started with Nikons, now we use Sonys, and this is Rich Walsh, one of the science divers who works with us. This just gives you a summary of the track lines that we used for multi-beam, side scan sonar, and sub-bottom profiling, which we did most of that together at this, deploying those instruments at the same time. And we would go, I mean, some of these are over 16 kilometers in total length, and with an interval of sometimes of less than 2 meters. So the degree of resolution that we're going to get from these data is quite remarkable. And here you can see the side scan sonar map of the area with those little submerged islands, we might call them, which actually contain remains of archaeological features, and then these areas don't, okay, due to site formation processes and so on. We laid a grid over the area, and these, a 25 by 25 meter grid over the area, and these 6 squares are the ones that we use to do our photogrammetric study of the remains on the seafloor. This gives you a sort of topographic map showing you the slope from about minus 4 meters below the sea level here to minus 9 over here. And this is the track lines for the sub-bottom profiler, just to show you that high degree of resolution. Nisia Cooley islet is again about 500 or 600 meters southeast of this, the main area of occupation of the site. The majority of the site is about 20 feet or 4 meters below sea level on the seafloor. And here we have, well, I just love, you know, you wake up in the morning, you have a little Rembetika music, and then you start your day. It can't be better than that. And then you can see the remains of a Venetian fortress in the background. And this area is really ideal for a deep time study of human settlement off the coast of Messenia, and it can contribute to enhancing the local economy of the people who live in Methoni today, and that's one of our goals as sort of cultural heritage. Here you can see our squares that we did photogrammetric studies of, and then it's superimposed on the side scan sonar data. And these are where it says T10, T9, and T4, and so on. These are targets that the geophysicists suggested that we we go and dive on to see what kind of archaeological remains, if any, might be on the site surface. And so we could use our underwater photogrammetry system to record them. And basically we use these piranha diving scooters, and we could use them for surveying, but we could also use them for the underwater photogrammetry system. And here we are at target number 4. Rich points it out, and then we just swim over the surface. This is non-invasive, no collection of data, taking remains out of the sea or anything like that. And then once we identify a target, we can dive down on it using the scooters. And here you can see a really impressive stone line circle from the Middle Helladic period that Elias Spondylis first recorded in about 1985. And that was when this underwater submerged site was first identified. So there's a great deal of potential here for a long-term study, which we hope to do. And just to give you a feel for how the 3D rig works, let's follow Tony Tamburino as he has an intervalometer on the top of this device so that all 3 cameras fire at the same time. And at the end of one of these tracks through a whole, a 25 by 25 meter square, we can collect around 9,000 images, and then using PhotoScan Agisoft, we can process those data into 3D models and maps for archaeological interpretation. This is the point cloud from one of those 25 by 25 meter squares. And you can see the corner markers there that we put down before we do the work. And here's a map, if you like, of that circle, which is about over 6 meters in diameter. And you can easily create site plans of it. And these are some of the other wall features associated with it. And then this is to the north in squares J12 and J13, more archaeological features. Basically all those submerged little islands that I mentioned are actually the collapse of buildings of some kind. So they're, to use an old-fashioned term, manuports. And here we can see these 2 areas separated by almost 100 meters, where you can see that a lot of the wall features are sort of laid out in a general east-west, northeast, southwest orientation. So if you spent more time, you could identify more and more walls here of this site, which is again submerged by about 4 meters of water. Now, if you remember, we looked at the site surface. On the site surface, you have all these collapsed wall remains and so on. And that is what we are observing here, the exposed submerged archaeological site. But this same signature, when you look at it with the sub-bottom profile data, it dips under the sand layer of the site. And it shows us that the Paleosol on which the Middle Helladic site was formed is now covered with a layer of 1 meter or more of sand, okay, on the seafloor. So the site is much larger than we anticipated. Today, there's about 3.5 hectares of visible site. But if we use the sub-bottom profile data, we can see that it's probably more like 12 hectares of site under the sand cover in this area. So if Nisiakuli is down here, occupied in the Middle Helladic times, and probably there was an altar found there, so it's a ritual site. This submerged settlement may have backed up to that small islet. So the big question is, how did this site become submerged? And maybe we can talk about that in the questions. I just want to close by showing some of the photogrammetry work we did over we did 2 photogrammetry studies of submerged shipwrecks that were first recorded and published by Peter Throckmorton and John Bullitt, pioneers in underwater archaeology. Back in 1963, they published it based on their 1962 work off of Sapienza Island, which is just opposite Mathoni. So let's just quickly look at that. And here we are on our way to the survey with the underwater team, and we're headed to the so-called column wreck that you see here, mapped to a very impressive degree of precision by the earlier researchers, by Throckmorton's team, just using tape measure, waterproof tape measures and a plane table underwater, using very traditional kind of surveying surveying techniques on land, but using it underwater. And we were able to compare their measurements to the photogrammetric data and show that they were spot on with the measurements. But what they couldn't do is like estimate volumes of these columns and so on to the degree that you can do with photogrammetry, and also to contextualize the actual event of the shipwreck. Like, how did it happen? Well, we can take a 3D view of the submerged landscape and these rock features and see that they just, if they had maneuvered their boat like 3 meters in a different direction, there wouldn't have been a shipwreck. But so this is just some of the data we can get from this. That's just a 3D model of the columns from the column, some of the main columns from the column wreck. And so coming back to close the lecture, so the Scripps Center of Marine Archaeology works very closely with our Center for Cyber Archaeology and Sustainability here at the Qualcomm Institute at UC San Diego. It's a center of excellence for information technology and telecommunications. And the mission statement for Cal IT, or Qualcomm Institute, is inventing a persistent collaborative research and education environment as a model for the major research university in the 21st century. And those are big words, but I think it really does reflect the vision of this place. And also it reflects what people interested in transdisciplinary research are trying to achieve around the world, okay? And that's exactly what we're doing with the University of Patras and the University of Haifa. And here you can see one of those large-scale 3D visualization environments at the Qualcomm Institute. It was basically invented by my colleague, Professor Tom DeFonte. And basically it's 70 passive large 3D TV panels with 500 megapixel resolution, and you can drop these whatever models you have into it. And here you can see one of the temples at Corinth. That this was from a project that we did with the American School of Classical Studies in Athens a number of years ago. But you can revisit the site and think about your data in new and innovative ways. And here you can see we're exploring the Mathoni data set in the Sun Cave in 3D in a very relaxed environment where it's easy to breathe. And this is this research, you know, with the cyber archaeology, both terrestrial and underwater, it grows out of the UC San Diego Research Cyber Infrastructure program, where we were an early adapter, along with Scripps oceanographic researchers, along with the San Diego supercomputer and their geology program, because all our data is, it's based on a geospatial database, X, Y, and Z coordinates, whether it's archaeology, oceanography, geology. Okay, we're almost there. And then ultimately, as I mentioned, the data, the data, whether it's 3D or photographs and what have you, it should all be offered up as a kind of digital collection. And that's what we've done with our Chibet and the Haas project and other projects, and we're in the process of doing it for our underwater work as well. So I mentioned at the beginning, we had a conference here in 2019 with the University of Haifa and the Israel Antiquities Authority, and the results of some of that is coming out in a book later this year called Mediterranean Resilience, Collapse and Adaptation in Antique Maritime Societies, edited by Asaf, Gil Gambash, and myself, and that's with Equinox. So with that, I would like to say thank you, and it's been great being with you.
So,
אז נתתי הרצאה לכבוד ארווה על הנושא של הפרויקטים של Scripps Center Marine Archaeology, והשיתוף פעולה עם כל מיני מוסדות במזרח התיכון, בעיקר אוניברסיטה חיפה ואוניברסיטה פטרס ביוון, וניסיתי להסביר איך השיטות שלנו, זה כולל marine geophysics, קידוחים, וגם חפירות בסכרים תת ימי. אי אפשר לעשות את כל העבודות האלו בלי תקציב, ולמזלנו קיבלנו סכום די גדול מהקרן קורט בסן פרנסיסקו, וזה עזר לנו מאוד לבנות את השיתוף פעולה עם אוניברסיטת חיפה. וניסיתי להסביר שאוניברסיטת חיפה הם חלוצים בנושא של ארכיאולוגיה תת-ימי. זה דבר מאוד גדול, והם הכי טובים בנושא הזה, לחפור מתחת המים. אז אנחנו לומדים מהניסיון שלהם, ומנסים לשפץ את כל מיני כלים של מחקר תת-ימי ביחד. אז, וזה רק ההתחלה. עכשיו אני עובד עם פרופסור אסף יסור לנדאו, מ-2017 התחלנו לעבוד בשטח, ואנחנו ממשיכים, וגם הסברתי שעכשיו יש, זה נקרא בית ספר לארכיאולוגיה, זה לא, שאוניברסיטת חיפה בונה עכשיו, זה לא בדיוק בית ספר, זה מוסד ענק עם 4 מחלקות, וה-Scripps Center Marine Archaeology וה-Center for Cyber Archaeology, אנחנו עובדים בשיתוף פעולה איתם, כדי לעזור להם לבנות את הבית ספר החדש לארכיאולוגיה, בסדר גודל בינלאומי, ויש הרבה תקווה בזה. אני חושב, העתיד של כל מיני מחקרים, זה יבוא ממוסדות מקומיות, כמו בארץ וגם ביוון. בגלל יש להם את היוזמה לעבוד גם שהמצב קשה, כמו עכשיו עם כל הסיפור של הקורונה, אף אחד לא מורים את הידיים, אפשר להגיד. טוב, זה על רגל אחד, בעברית פשוטה.
אוקיי, תודה רבה.
עמודי, העברית שלי זה כפור ב-1992 בעצם.
Okay. Thank you very much again, Tom. I remember